piles. A mission to a near-Earth comet would also be of great scientific value, and if you remember, we have discovered 84 near-Earth comets. So I would think maybe a few missions, maybe 4 to 6 missions to near-Earth asteroids might be about the right number. And if you combine that with the other missions and the flexible path strategy, such as the missions to the Lagrange points and the flyby of Mars and orbiting Mars, that would make about 10 missions, which would be comparable to what was done in the Gemini program in order to prepare for a human landing on the moon. So I think this strategy could make a human landing on Mars, a safe proposition. I think you could do it safely once you've done a strategy such as the flexible path. So my conclusions are that the flexible path strategy, followed directly by a human Mars program that is no detour to the moon, is really the quickest and way that we can safely achieve our goal of landing humans on Mars. This strategy is better, in my opinion, than the Moon First strategy in several important aspects which I've already discussed. But to make it happen, we really need more funding and a more aggressive schedule to help ensure the success of the program. So thanks very much. Maybe have time for 1 or 2 questions. Okay. Can you use the mic, please? Okay.
Just quickly, Dr. Griffin suggested that windows and delta V's to asteroids weren't so plentiful as you might imagine. Do you agree or disagree with that assessment? And have you a good list of targets?
Well, there are a good list of targets. Lockheed Martin came up with a very good list of targets. For lack of time, I didn't put their list on the board, but there are several launch opportunities, and they require very small delta V's. If you're going to go to the larger asteroids, then they would require bigger delta V's, but there's no reason that you can't start off small. That's correct. That's correct.
I was wondering what percentage of your total fuel you'd have to use in order to brake, in order to slow down when you get near that asteroid.
Probably a very small percentage. I haven't worked through the numbers, but I would think it would be a very, very small percent.
Well, I mean,
it's mostly you launch when Earth is close to the asteroid, and you pick an asteroid that has, is almost crossing the Earth's atmosphere at that point. So your delta V, your main delta V is the initial burn, and then you're pretty much on the same path with a little bit of coasting and a little bit of deceleration when you get close.
Oh, so you're at similar velocities? In other words, you don't...
Yes.
Ah, okay.
The asteroid has a very similar velocity to the Earth at takeoff. Yeah.
Low inclination, low eccentricity asteroids.
Right.
One astronomical orbit setting on a major axis.
Okay, my time's up, so next speaker. Okay. If there's any more questions, they tell me I can take one more.
Either's fine. Yes.
Potentially hazardous asteroids. Are they typically easier to get to than generic asteroids, or is it statistical fluke that they have to be hazardous?
The near-Earth asteroids would be harder to get to because those are larger size ones, and the ones that are most accessible are smaller size asteroids. But you could certainly, on a second or third mission that would last a year or more, you could get to one of the more hazardous ones, certainly.